Hello everyone, this is Madhavi Karmudi, Assistant Professor in CLC Department. In this lecture, I'll talk about preprocessor directives. In any programming language, if you want to execute the program, first of all, we need to compile the program by using the compiler. But before the compiler compiles your program, there will be your source code will be processed by a software tool, or that will be processed by some other program called as preprocessor. So in C program, there are a lot of preprocessor directive statements are there. Every preprocessor directive statement starts with the hash symbol. And in any programming language, every statement ends with the semicolon. But if you are writing any preprocessor directive that starts with the hash sign, but it does not end with the semicolon. So no need to use semicolon at the end of the preprocessor directive statements. An important point is always these preprocessor directives are executed before the compilation. So here we have in C language, we have a lot of preprocessor directives, and all those preprocessor directives are divided and grouped into 4 categories. Those 4 categories are: first one, macro substitution directives; second one, file inclusion directives; third one, conditional compilation directives; fourth one, miscellaneous directives. So macro substitution directives means here we will define the macro. Macro means it is a simple piece of code in a program. We will define a macro with some name. Whenever the compiler identifies that particular name, that name will be replaced with the macro definition. Okay. See, to define the macro in C language, we will use hash define preprocessor directive. So hash define directive is used to define the macro. So we can define these macros in 2 ways. We can define object-like macros, or we can define function-like macros. So how to define the object-like macros is, here every macro contains one name that is identifier, followed by there will be some value. So whenever you define some value to that variable, automatically whenever you use that variable in your program, that variable will be replaced with the defined value. Okay, so this is the statement for defining the object-like macros. Okay, here I am defining object-like macro name is X and value is 25. So in my program, wherever compiler identifies X, that X value will be replaced with 25. Right? See how to define the function-like macros. So this function-like macros looks like a function call statement. So how the function call statement will be written in the functions? Simply we'll write the function call statement. Whenever the function call statement is written, automatically control jumps to the function definition and it will execute the complete function definition, right? Similarly, here also we will define the function-like macros just like a function call statement. See, here also we will define it by using hash define statement. Here I am defining the function minimum function. So min of a comma b. This is similar to function call statement, right? Whenever, and here in this case, min of a comma b is a macro name. In my program, wherever I use min of a comma b, automatically this macro will be replaced with this definition. This is the definition and this is the name of the macro. So this name will be replaced with this definition. Like this, we can define the macros using hash define directive in C language. Now see the second category of directives. These are file inclusion directives. So these directives are used for including header files to your source program, or sometimes we can also include some other source files to your C program. Okay, so for including external files to your C program, we'll use file inclusion directives. So these file inclusion directives are specified or included by using hash include directive. So for including external files, we'll use hash include directive. This hash include directive is a file inclusion directive, right? Now see, suppose if you want to include this header files or standard library files. Okay, why we need to include standard library files? Generally in our programs, we'll use printf and scanf functions directly, right? Without writing any definitions. So the definitions of printf and scanf is available in stdio.h library file. So whenever you include stdio.h header file to your program, before the compilation, your preprocessor directive executes the state printf and scanf statements, and that executable code will be attached to your source program. That is the reason why even in your source program, if you are not writing definitions for printf and scanf also, it is giving correct results, right? So to include header files or to include standard library files to your program, we'll use #include directive. This #include is one of the file inclusion directive. Let us see second way of including files to your source program using #include directive is, just assume that my program name is function1. Now I want to include function2 also in my program. So in that case, what I need to do is, I need to include function2.c file by using include statement in my function1.c file, right? See how to define that one is, how to include external files by using #include directive is, this is the syntax, #include name of the file. That name should be, we need to give inside the double quotes. Suppose if you are including predefined library files, then that library file we need to write in between the angular brackets. Suppose if you want to include user defined files to your C program, then we need to write that user defined file name in the double quotes like this. Okay, just assume that my function name is, my program name is function1.c. In my function1.c, I want to include hello.c file. Okay, so here I am including hello.c file by using #include statement by specifying it in the double quotes. Let us see the third category of directives. Third category of directives are conditional compilation directives. Okay, so these conditional compilation directives are used for checking conditions. Whether this condition is true, then that particular block will be executed. If that condition is false, another block will be executed. To specify or to control the flow of execution also, we will use some of the preprocessor directives. See the preprocessor directives available under conditional compilation category. So first one is #ifdef directive, #if directive, #else directive, #elif directive, #elif means else if, and #endif directive, #ifandef directive. Let us see the use of all these directives with examples. So first one, #if directive. So this #if preprocessor directive is used for checking the condition. Okay, for this #if directive, we will pass the expression. Your preprocessor directive will evaluate the expression. If that expression is evaluates to true, then whatever block that follows this #if, that block will be executed. Suppose if that condition is evaluates to false, then simply that if block will be skipped by the compiler. Okay, see the syntax of writing #if directive. This is the syntax, #if expression, okay, then followed by set of statements. Suppose if this expression is evaluates to true, then this code will be executed. Suppose if this expression is evaluates to false, then simply this block will be skipped by the compiler. Okay, now see one example program for this. And one more important point, before seeing the example, we'll see here at the end of the #if directive block, we are writing #endif directive. Okay, we are using #endif directive. So this #endif directive is used for closing if directive and closing else if directive, and for closing else directive also, we will use all this endif directive. So for closing all the conditional compilation directives, we will use #endif directive. Okay, now see one example for #if directive. So here I am including the standard library file by using #include directive. In the next statement, I am defining the macro, object like macro, by using #define directive. So here my macro name is number. The value of that macro is 1. So in my program, wherever I use number, that will be replaced with 1. Okay, now see the execution starts from the main method. inside the main method, what I am doing is, here I am using Hashif directive. Okay, so for this Hashif directive, I am passing one expression. Here that expression is number equal to 0. Okay, here what is the number? Number is a macro. So the value of that macro will be replaced here. So here the number is 1. So this number will be replaced with value 1. So 1 equal to 0. 1 equal to 0. It is false, right? If that expression is evaluates to false, then if block will not be executed, right? So this if block will be skipped by the compiler, right? Now see the next directive. Here I am writing else directive. We will discuss about this hash else directive in the next slide. So this hash else directive is used for just reverse to the Hashif directive. Your Hashif directive evaluates to takes one expression. If it evaluates to true, that if block will be executed. But in case of hash else directive, if the expression evaluates to false, then else block will be executed. So here in this case, this expression is evaluating to false. So if block will not be executed, so your compiler executes the hash else block directive. Okay, so here it will print the value of number is non-zero. That statement will be printed on the screen for this program as a output. Okay, for closing all Hashif directives, hash else directives, or hash if and directives, hash if def directives, will use hash and if directive. Okay, so for closing all the conditional compilation directives, we'll use hash and if directive, right? See the next directive, that is hash else directive. Just now I told you this hash else directive is just reverse to the hash if directive. So for this hash else directive also, we will pass the some expression. If that expression is evaluates to false, then hash else block will be executed. Okay, so see the example, see one example. So generally this hash else block will not be used separately. Always this hash else will be a processor directive. Hash else directive is used along with either hash if or hash if def or hash if and def or hash else if. Okay, so if you want to use hash directive, compulsory that should be included with either if directive or else if directive or if def directive or if and def directive. But solely you should not use hash else directive in your program, right? Now see the syntax of writing using hash else directive with hash if. Okay, now see hash if expression code along with hash if we are using hash else, right? Suppose in this case hash if directive expression is evaluates to false, then hash else directive will be the code that is comes under hash else directive will be executed. So we are closing these two directives by using hash and if directive. Now see how to use this hash else directive with else if. Okay, see elif means else if. So hash if expression, if this expression is true, this if block will be executed. Or here we are checking one more condition. Okay, we are checking one more condition after this. If this expression is evaluates to true, then else if block will be executed. If both these two blocks are fails, expression fails, then hash else block will be executed, right? So what we can understand from this syntax is, we can also use this hash else directive along with hash else if. Okay, and to close all these directives, we will use hash and if directive. So this is about hash else directive. Now see the next one, hash elif directive. So this is used to write hash else and hash if in one statement. Okay, so this is just similar to else if statement in the program, right? Now see the next important directive, that is if def directive. So this if def directive is used, suppose here the hash if def processor directive takes one macro, okay, if that macro is already defined by hash defines directive, then hash if def block will be executed. Suppose for that macro, there is no definition found by using hash define directive, then hash if def directive block will not be executed. Okay, see one example for this statement. First, see the syntax. Okay, so this hash if def directive is also, or hash if def processor directive also ends with hash and if directive only. Okay, first see the syntax, then you can easily understand. After seeing this syntax, we'll see one example. Here, I am writing hash if def directive and followed by I am using some macro name, right? Suppose if this macro, for this macro, if there is a definition in your program by using hash define directive, then this block of statements will be executed. Suppose in your program, there is no definition for macro name by using hash define directive, then your block will be skipped by the compiler. Okay, this is the meaning of hash if def directive. See one example. See one example here. So in the first statement, I am defining one macro. Here my macro name is S1, right? The value of the S1 macro is hello. So inside the main method, I am using if def directive. Okay, for this if def directive, I am passing one macro name S1, right? Suppose for this S1, if there is a definition by using hash define statements, then this if def block will be executed. This if def block will be executed. See only these three statements. Don't see the remaining three statements. See only these three statements, right? So here in our example, here for S1, there is a definition by using hash define, right? So in this case, it will print the value of S1. That means the value of S1 is hello. So this statement will print the hello message on the screen, right? Suppose just assume that in your program, there is no definition for S1 by using hash define statement. Just assume that there is no first line in your program. In that case, your if def statement block will not be executed, right? So that is the meaning of if def directive. If def directive, okay, takes one macro name. If that macro name is defined by using hash define directive, then if def directive block will be executed. If for that macro there is no definition using hash define directive, then if def directive will not be executed, right? See the next conditional compilation directive, that is hash if and def directive. So this hash if and def directive is just reverse to hash if def directive. Okay. So for this directive also, we will supply the macro name as a value. I mean, it will take the macro name. If that macro name is not defined by using hash define directive, then if and def block will be executed. Suppose for that macro, if the definition is defined by using hash define directive, then that particular macro will not be, then that particular if and def block will not be executed. Okay. See the syntax for if and def. See here, hash if and def macro. What is the meaning of if and def is? If there is no definition for this macro, then execute this code. Okay. So that is the meaning of if and def. What is the meaning of if def? If there is a definition for this macro, execute the set of statements. Hash if and def means if there is no definition for this macro, then execute this block of statement. This is just refers to hash if def directive. See the example. Okay. Here in my example, same example I am showing here also. In my example, I am defining S1. Okay. So for S1, the definition is hello, right? Inside the main method, I am writing if and def directive, if and def directive, if and def S1. What is the meaning of if and def S1? If there is no definition for S1, then execute this block. If there is a definition for S1, skip this block, right? But in our program, there is a definition for S1. So in this case, this if and def block will be skipped by the compiler. It will not be executed. So it will come to the next statement. So in next statement also, I am writing if and def statement only, right? So for this if and def statement, I am writing the macro name as S2. So here, what is the meaning of this statement? If there is no definition for S2, execute this block. Okay. Now the compiler searches for S2 definition. Unfortunately, here there is no definition for S2, right? If there is no definition for S2, it will execute this block. So it will print the S2 value on the screen. Are you clear with this example? If there is no definition for this macro, then it will be executed. If there is a definition for that macro, it will not be executed. That is the reason why first block is not getting to execute. Only it is executing second block. So for closing each and every directive, conditional compilation directives, we'll use #undef directive. So for closing this #if and def directive, here we are using #undef directive. For closing second if and def directive, here I am using #undef directive. Okay, this is the meaning of #if and def directive. Now see the fourth category of directives, miscellaneous directives. Okay, see here we have two miscellaneous directives. Actually, there are multiple miscellaneous directives, but frequently we use these two. Okay, first one is #undef directive. So what is the meaning of this undef directive is, you just remove the definition, undef, remove the definition. So whatever definition that you have defined for a macro using #define directive, for that macro, it will cancel the definition by using undef directive. Okay, by this undef directive cancels the definition of the particular macro. So see one example. First, okay, see this example. So in this example, first I am including header file. Okay. Second statement, I am defining the macro. Here my macro name is pi, right? So the value for that macro is 3.1415. Here I am defining value for pi, right? Using #define directive. Immediately the next statement itself, I am writing undef directive. So what is the use of this undef directive? This undef directive cancels the definition of macro. So with this statement, the definition of pi will be cancelled. So in next statement is main method. Inside the main method, I am trying to print the value pi. So what value this statement will print? It will return the error. Because before this printf statement itself, we are undefining the value of pi by using undef directive. That is the reason why here we are unable to print the value of pi. Okay, so this statement will return the error. So #define directive is used for defining the macros. #undef directive is used for cancelling the definition for the macro. So next see the second category, miscellaneous directive, that is pragma directive. So this pragma preprocessor directive is used for giving some additional information to the compiler. Suppose other than its job, what is the job of the compiler? Compiler will compile each and every statement and it will convert each and every statement into machine readable format, right? So if you want to give any instruction to the compiler that instead of executing this function, execute some other function, or you just stop this function, execute another function. This kind of statements, if you want to give it to the compiler, then that can be supplied by using hash pragma directive. Okay, so it is very dangerous to use this hash pragma directive. So it is not recommended to give the instructions to the compilers. You just use the services of the compiler, but don't recommend the compiler to do some kind of tasks. Sometimes it may leads to the errors. Okay, actually it is available. We can also give some additional information to the compiler to do some tasks that can be done by using hash pragma directive, but it is recommended not to do it, right? These are the two important miscellaneous directives, right? So in this lecture, we have discussed about various preprocessor directives. So in next class, we'll see another topic. So thank you.